Hello everybody, my name is Jim Pingle, and this is our November 2015 Hangout on Site VPNs. This month, we're just going to cover some basics here of Site VPNs. First, we're going to go over some project news, go over just the nuts and bolts of what a Site VPN is, conceptually, and why you'd want to use it, that sort of thing. Limitations or drawbacks to using them, kind of qualities of policy-based and routed VPNs, some prerequisites, comparing IPsec and OpenVPN a little bit different than what I compared IPsec and OpenVPN with for remote access the last couple of months have been talking about, because they have a little bit different qualities you want to consider for site to site. Talk about OpenVPN Shared Key and PKI, just because there are a couple of different ways it can operate. I'm going to do a quick demo where we connect two different sites. I'll show you one how to do it in IPsec and one how to do it in OpenVPN. And then I'll just, I don't have a demo set up for connecting many sites, but I'll discuss how you can go from like a 2-site to a many site type deployment. It's fairly easy to add sites on. And there should be some time for questions and answers at the end. So if you have any questions, you can type them out as you think of them, or I'll kind of get to them toward the end. But I usually check periodically throughout. But mainly toward the end, we'll have question and answer time. And I will warn you though, sometimes it takes a while to type. I need to know you've got a question coming, so you might just send a quick message to chat. Let me know you've got a question coming, and then type away. All right, so everybody, we'll get started. First up in our project notes, our 2.2.5 release version is out. If you're on an older version, especially an old 2.2 version already, you want to get up to 2.2.5. The release notes and changelog and all that stuff, they're on the blog and the wiki and everything. It's a really good release, so you want to get up to that as soon as you can. Every one of us here, we're all working on 2.3 now. We're hoping for a beta very soon. It could even be next week. But with the holidays coming up, we're not sure on the timing, but there will be a beta pretty soon. We're all using 2.3 at home. We're all dog fooding it on our home networks. All the developers and a lot of the support personnel, if not all of us by now. So it's getting a lot of good testing and a lot of different scenarios for us. With VPNs, and we've all got crazy stuff like multi-WAN and all sorts of crazy local network setups, multiple interfaces, bridges, who knows what we've got. We've got some public alpha snapshots of 2.3 if you want to give them a try at snapshots.pfSense.org. We still don't officially recommend it for use in production. However, they're really good right now. A lot of us are using them in production at our homes. Be a really good time to get into it and start using it, especially in a lab or test setup. If you have any concerns about whether or not what you're using is going to work in 2.3, if you've got a lab or a way to replicate what you've got, now's the time to start loading 2.3 up and try it out. And mock it up or give it a trial run, because if we find, now's the time to find the things that don't work and let us know. And if you do load it up, our Bootstrap GUI is just needs a little bit more polishing and some testing here and there. We're still finding just little things here and there that need some adjustment or reformatting, things like that. And if you find anything like that, let us know, either on the forum, ticket system, wherever. Just a word on our training. We had some classes set up from now to the end of the year. Those are all booked. We are going to have some more classes next year, obviously. Don't know timing on that, but as soon as we have more classes, we will post those ASAP. All right, so let's get started talking about VPNs. First off, what is a VPN? Most of you probably already know, but it's a virtual private network. You connect two or more remote networks as if they were connected directly, especially if there's a lot of networks in between, not just the internet, but also private links, things like that, or private internet, or even just two local networks that are across another larger network. And it encrypts the traffic in most cases for secure communication across untrusted networks, typically the internet, but technically, if it leaves your building, you want to encrypt it. So even if you're paying for a private link, you typically, especially depending on your industry regulations, you're supposed to encrypt it if it leaves your building. So why would you want to use that? Obviously, it's a secure means of accessing resources between sites. It also makes things easier. protects your sensitive data being transferred between sites if you've got anything, account information, that sort of stuff, or customer data. You don't want that exposed to the public. You can easily access resources without exposing them to the public. Now, a lot of people are really tempted to just set things out for the world to see, like security cameras or local systems that vendors need to get in and access, things like that. We talked a lot about that during the remote access VPNs, but it works also from site to site. If you've got a home office and they have your accounting or whatever's there, and they need to get a point of sale system or something, you'd want that to flow over a site to site VPN. You would not want to expose that sort of stuff through a port forward to the world at large. And where would you usually see it? Typically at the edge of your network. You can have a VPN server on the inside of the network. It takes a little bit more effort with routing and forwarding traffic, and depending on how you're set up. But normally you see them at the edge, right at the end of the internet connection. It's certainly the easiest thing to do it there. And they should be employed anytime sensitive data has to enter or exit a physical premises to a known remote location, whether it's from a home office to a data center or between a central office and remote sites, or who knows what. If it's leaving your building, you want it encrypted. And now a couple of the drawbacks to using a VPN. There will be some added latency and delay to using a VPN. There's overhead for encryption and processing of packets because it has to go through some additional overhead of getting into or getting encapsulated, putting it in the VPN packet, encrypting it, and then putting it on the wire in an extra way, rather than just simply passing the packet or rewriting some headers. And so due to that extra processing, you're going to get some extra latency. It's unavoidable. And some protocols are especially sensitive to latency. The biggest one is older versions of SMB or Windows file sharing traffic. There are some cases too where if you're going from moderate latency to high latency with a VPN, depending on your threshold, you might also see some protocols like RDP sort of fall apart. But it really it's all down to the protocols you're using. Because the traffic is encapsulated, by its nature, it's going to have a smaller MTU. So you can't transmit as much per packet as you could, bear without the encryption and other overhead. So something to be aware of too. If you've got an application trying to blast a bunch of data, it might need to send it optimally would send packets that are a little smaller. You can nudge things like that with MSS clamping. A little bit out of scope for what we're talking about today, but there's ways around that. Lower throughput, obviously, you're going to have that because of encryption. That can be offset somewhat by encryption offloading. Like if you've got AES-NI enabled hardware and you're using an algorithm that's accelerated by AES-NI, such as ASGCM, then both sides can take advantage of that, and it may even pass up to your wire speed. But again, it depends on your wire speed, depends on your traffic. But there's just more overhead in general with encryption and all the extra packet processing because it's taking up more of a burden on the CPU and other areas of the firewall. So there's two main classes of VPNs on pfSense and elsewhere. Policy-based and routed VPNs are some terms you'll probably hear even dealing with other equipment. When I'm talking about policy-based VPNs here, I'm not talking about policy routing. Those are two different concepts. I'll talk about those a little bit. Policy-based VPNs are VPNs that are based on network policies at, at the kernel level, or security policies for IPsec, where the traffic is defined in like your phase 2 network definitions, where any traffic going from A to B is going to be claimed by IPsec and encrypted by that policy. Whereas policy routing is matching traffic with a firewall rule and then directing that at a gateway of your choosing. It's a little bit more a different concept, but similar names, two different kinds of policies. Just want to make sure you don't get the two confused. Policy-based VPNs, in pfSense, we only have policy-based IPsec at the moment. We don't have route-based IPsec. Some other vendors, like Juniper, they have route-based IPsec. It's something we'd like to see in the long road. I'm not sure how far off that is, but it's something a lot of us would like. But at the moment, we've just got policy-based, and that's the most common thing you're going to find in the wild on third-party equipment is policy-based. However, policy-based VPNs, they don't have a distinct interface address or a gateway or anything. All the traffic for an IPsec VPN on pfSense is going to flow through the ENC0 interface, which it's an unnumbered interface. You know, the traffic just sort of flows through that. It's handled into and out of that interface by the kernel and the IPsec stack and everything. So it's not routed in a traditional way. It's all handled by the policies. And it will claim all traffic matching a defined phase 2 policy. So if you define that, you know, traffic from 192.168.0.0 to 1.0 in a phase 2, you know, any traffic that tries to match that is going to be taken by the IPsec stack, whether or not the tunnel is up, or any number of other scenarios like that. And traffic that does match a policy, it's going to, if it is seen entering or exiting via an unexpected path, it's going to end up getting dropped. Like somehow, if that traffic were to come back a different path, it might get dropped. Now, policy-based VPNs cannot use policy routing because you have to define the policies in IPsec. It doesn't matter what you do in the rules, you're not going to be able to nudge that traffic into the VPN if it's IPsec, so long as that traffic, you know, if it doesn't match the phase 2s, it's not going to go. Also, when you're using a policy-based VPN like that, you cannot use routing protocols, so you can't use something like BGP or OSPF inherently in that to control the routing. There are ways that you can use those in, you know, like, I don't want to say through them, but there's ways that you can layer things on top of other things to make that work. Sort of like if you had IPsec in transport mode, which is a different special mode, with something like GIF or GRE on top, you know, you can run a routing protocol on that. Or there are cases like AWS that can employ BGP a slightly different way because there's some other static stuff going on. It's really not really using BGP a slightly different way. These IPsec policies, they override the routing table and they kind of ignore it. So any traffic that matches the policy, it doesn't matter if you have a route. They don't need routes in IPsec. The traffic's just going to be claimed. So even if it has a route saying that it needs to go out this other third interface or out WAN, it's going to be eaten by the IPsec stack and try to go out a tunnel. Now on the flip side, we got something like OpenVPN, which is a routed VPN. Each OpenVPN instance has a distinct interface. Whether it's a server, it'll be like OVPN S1. If it's a client, it could be OVPN C2, something along those lines. Each interface is going to, in most modes, is going to have an IP address on it. It might have a gateway specified, or it could be a peer-to-peer type, point-to-point interface type thing where it has, from A to B. If you have the OpenVPN interface assigned, pfSense will assign it a gateway as well automatically, so you can use policy routing. So you can match some traffic with the firewall rule and say, okay, this traffic is going to go across the VPN. You may need some special handling in NAT or return routing on the far side to make sure that comes back to you, but you can do policy routing with OpenVPN. You can use routing protocols in some configurations, like OSPF. If you're using like a shared key type setup in OpenVPN, you can use that. OpenVPN does respect the system routing table. It manages its routes in the system routing table automatically using the settings in OpenVPN. So you can either do things that way using like the remote networks to set up routes, or you can do policy routing. That's down to your configuration. I talked a lot about policy routing and doing other fancy stuff with OpenVPN last October in our advanced OpenVPN concepts hangout. So if you're interested in doing a lot of stuff like that, you might want to go back and watch that older hangout, and some really interesting stuff you can do there. A couple other high points here. The daemons on the firewall system can bind to the VPN interface. So they would answer to traffic on the VPN endpoint interfaces. And traffic from the firewall may be initiated from the VPN interface, which is important for things like NAT on the way out, or you can ping from the VPN interface itself rather than pinging from the LAN or one or the other. Now, before you can do anything with VPNs, there's a couple of things you need to make sure on your networks. The first one is that your LAN subnets do not overlap. If you've got two locations that have 192.168.0.0 on their LANs, you're going to have a problem because the systems couldn't tell each side apart, and you're never going to be able to build a VPN tunnel between those. So what you need to do is either renumber one of them or you can employ NAT. When you have uh, an overlap like that with NAT, the NAT has to happen on the side that can hide the conflict, basically. So if both of them conflict, they both have to do NAT. But say you've got a main office that's one network and you have two remote networks that are both on uh, the same network. Like say you've got O.O for your main network and you've got 1.0 or 1. Whatever at site A and 1. Whatever at site B for your remotes, then you could just have one of those perform NAT, or you could do NAT on both of the clients, but the clients have to do the NAT in that scenario to avoid the overlap. Same thing goes if you're hooking up to a vendor or whatever. If you're trying to avoid an overlap and the far side says they have an overlap, then they may need you to perform NAT before you expose your traffic to them. And that goes the same for whether or not you are on IPsec or OpenVPN. NAT and IPsec is pretty easy. I'm not going to get too into that today. It's just you just define on the phase 2 what you want NAT to do. With OpenVPN, you just use the system NAT rules just like anything else with NAT. Let's see. At least one side has to have a routable public WAN address. So you have to at least have one side that can be identified. You know where you're going to go to. IPsec is a little stricter. I'll talk about that in a minute. But some way or another, you have to be able to receive the VPN traffic from one side to the other, ideally in both directions. But at the very least, you need one side that's able to receive traffic, so the other side could initiate if they have to. If both sides can receive the traffic, then you can initiate either way, which is more stable or more robust. But if you have to, you can get by with just one. I'm not going to use any VPNs with this today, but if you do decide to have either an open VPN structure using SSL TLS or PKI, or you use RSA authentication with IPsec, you will need a certificate structure before you start. And you can manage that on the firewall under System Insert Manager. You need to make a certificate authority and then make a server certificate and a client certificate, or two server certificates for either side on IPsec. Just so you can distribute those to each end, and you can use those instead of keys. A little bit more overhead there, but it's a little bit more secure. So it's up to you what you want to do, but just be aware that before you go setting up the VPN, if you decide to go that way, you need to have that set up before you start. All right. Also, when it comes to using OpenVPN, you will need tunnel networks for each VPN. So you need to pick out some unused address space. Private network address space somewhere that doesn't conflict with anything you've already got, just set aside to use by the VPN. All right, a little bit about IPsec versus OpenVPN to compare and contrast a little bit. When it comes down to it, you can accomplish a VPN tunnel with either one. In most cases, they work equivocally. Some people prefer IPsec, some people prefer OpenVPN. IPsec, the way it's coded in FreeBSD, is going to tend to be a bit faster than OpenVPN. There's less overhead involved, and it can take advantage of more acceleration. OpenVPN, on the flip side, can be a little bit more stable in terms of keeping tunnels alive. And so 6 of one, half a dozen of the other. But in most cases, you can connect up using either one of them with minimal effort, especially just for a simple one site to one site type thing. Both of them will work fine with high availability and CARP. Both support having one or both endpoints as dynamic, as long as you can receive traffic on at least one side. With IPsec, it's accomplished with dynamic DNS. You have a dynamic DNS host name set on each side, and then your peer addresses, you use that host name to identify the other side, and they'll track each other through DNS and adjust things accordingly and try to keep the tunnel alive. If your IP address changes, obviously you're going to have a few minutes where it's going to be down when it updates the address, but there's not really a real good way aside from doing the dynamic addresses to track that. OpenVPN, the clients can be completely dynamic. They can come from anywhere if you want. You could, have a similar restriction with the dynamic DNS if you want to be strict with your firewall rules and have an alias with a host name, for the source. But most people just let the OpenVPN traffic hit from anywhere. But you can, with OpenVPN, again, a little bit more flexibility there, but a little bit less security because it's not as strict as IPsec and where it verifies the source. Both of them support IPv6. IPsec with IPv2, you can carry both IPv4 and IPv6 at the same time. OpenVPN, doesn't matter which config you choose to do, you can do both IPv4 and IPv6 at once. If you try, you can't do that with IPv1 and IPsec. You'd have to have a separate v4 and v6 tunnel. But for just one tunnel, if you're doing IPv2 or OpenVPN, it'll work either way. IPsec is a widely accepted standard, and you'll find that most commonly in third-party equipment. So if you're connected to a vendor and they've got, Cisco, Juniper, FortiGate, whatever, WatchGuard, you're probably going to end up using IPsec to connect to them. IPsec at the moment is the only one that supports AES GCM, which is a really fast accelerated cipher. It has the hashing built into the encryption algorithm, so it doesn't need a separate hash. It's super fast when accelerated by AES-NI, so it blows the doors off of everything speed-wise. OpenVPN does not have that yet. They say it's going to be in the next major version. I don't know if that's actually in there yet in their code base or if it's just still a pipe dream at this point, but they claim it'll be in the next major version. So be on the lookout for that there, but it's not there yet. I mentioned before, IPsec on pfSense is policy-based, not routed. So if you need something that's route-based, you'd have to go with either OpenVPN or, like I said, you can pile GIF or GRE on top of IPsec in transport mode, but that gets kind of hairy really quick. So OpenVPN is a bit more flexible in how it operates and things you can do with it. If you assign the OpenVPN interface, the system will assign it a gateway. You can have individual filtering per VPN tunnel. You can use policy routing, a little bit more flexible with NAT and how daemons and things bind. So they're treated pretty much just like any other interface on the firewall when it comes to OpenVPN rather than the special treatment that IPsec gets. OpenVPN has no issues with the clients being behind NAT, or even if the server's behind NAT, you just forward in one port and that's just fine. IPsec has a lot more trouble with NAT. There's NAT traversal, which helps in IPv1. IPv2 has that built in, but still you can have issues with identifiers and other things in certain cases and modes. It can be tricky either to establish a tunnel at all or to keep it established. Let's see, where was it down the line here? Oh, OpenVPN, I'm not sure I'd consider this an advantage, but it is an extra capability. You can run OpenVPN on TCP. You don't generally want to do that because if you're running TCP traffic inside your tunnel, you can get compounded loss. So like if the TCP inside the tunnel will retransmit along with the TCP outside the tunnel retransmitting, and it just ends up in a big, flaming ball of death. But if you are in such a bind where the only traffic you can get out or into a specific location is TCP, then OpenVPN, it's a viable choice. Not ideal, but it can get the job done. OpenVPN can easily accommodate routing protocols like OSPF. Like I mentioned before, you can do that in IPsec if you're willing to get a lot more complicated with it, like transport mode and GIF and GRE. Very ugly, but it can be done. Let's see. Both of them will do multi-WAN in different ways. Again, last October, I talked a lot about that with multi-WAN and OpenVPN. At the very basic level, they can both support a gateway group as their interface, so they can run on one interface or another. OpenVPN, you could also set it up to where one tunnel is bound to both WANs, or one client. Clients and servers can each connect using multiple IP addresses and things like that. So. OpenVPN, you can like pin up tunnels in every WAN and use a routing protocol like OSPF to handle the failover. So lots of different choices to do for multi-WAN, a lot more than we'll get into today, but we have a lot of that detail on last October's Hangout and in the book and things like that. And last but not least, the IPsec and OpenVPN, they can both coexist peacefully as long as they are trying to pass different traffic. You can't try to do the same traffic between the same two sites over both kinds. Like if you have two sites, A and B, you can't have an IPsec for A to B and then OpenVPN from A to B. The OpenVPN would never work because the IPsec would always grab the traffic. So you can't have, like, say, a failover between IPsec and OpenVPN, at least not automatic. If you, like, say, if you had OpenVPN and IPsec and you enabled one and disabled the other, that could work for whichever one's enabled. I got somebody. David says, are there any slides? Yes, the slides will be posted along with the video later this afternoon. You can get the slideshow. And all the previous presentations have slides available too. Okay. OpenVPN has two different modes you can operate in. Talked about this the last couple of months with remote access, but with site to site, it's a slightly different conundrum. You have two different types, shared key and PKI. With shared key, you need one server per client. So you have separate server instances for every remote site, for example. Each would be on a unique port. So like say your first one would be on 1194, the second on 1195, third on 1196, and so on. Each one would have a different tunnel network. Though with shared key, it's just a little like a /30. So you don't need to allocate that many IP addresses. So you just would keep going on and on and on up. You can get a lot of mileage out of like a /24. You could have 64 clients out of it, or VPNs out of it. And shared key tunnels like that easily accommodate routing protocols like OSPF. With PKI or SSL TLS, it's a little bit less overhead on the server because there is only one server instance. However, you do have to have a certificate structure set up, and each client site has to have a unique individual certificate with its name as the common name of the certificate. And then you list the networks that you want to route in, or to the networks you need to route in general are listed in the OpenVPN server so that the operating system knows those go into OpenVPN, and then you have to set up client-specific overrides to define which subnets go to which certificate. So you have to map that out two different ways. So the complexity you save in having the one server just spills over into having to have the overrides. So there's administration either way, but you need to be wary of that. And there are some special circumstances with SSL TLS where you can use a routing protocol like topology subnet, but that is very it's not very well tested. Not very many people have tried that. I think I heard one or two customers getting that working, but I don't know the how long they've run with that to know if it's something they'd want to keep doing. So there's kind of a trade-off here. If you've only got maybe half a dozen sites, shared key is going to be just about the same or a little bit easier. Beyond that, it kind of gets a little bit easier to go with PKI or SSL TLS. So you just have to worry. It's all a matter of choice. You're free to use whichever way you want for as few or as many tunnels as you want. But if you're going to have a lot, you might steer toward more the SSL TLS way. If you only think you're going to have a handful, or you're going to add them very slowly over time, shared key would be just as easy. Okay, well, let's just do a quick little demo here to connect these two sites with IPsec. So on both units, you just need to go to VPN IPsec, make sure it's enabled. And then once you've enabled it, just save it. And then once it's saved, you just need to make your entries here. You add click down here, you add a new phase 1 entry. I'm just going to edit the one I've already got, just show it to you. I have set the remote peer address. This is the other side of my tunnel, this VPN right next to me here, or the firewall right next to me in the next tab. I'm using IKV2 for this because I know both sides support IKV2 because they're both pfSense. Whether or not you use V2 or V1 is between you and the other piece of equipment. If both sides supports V2, it's a good choice. Unless the far side is an ASA, a Cisco ASA, then you may want to stick to V1. V2 can work in some circumstances there, but we've had several reports of issues. Somebody asking, David, should I see your screen as you do this? Yes, and the screencasting is working. I'm watching it on a second client. So you might want to, if you're not seeing the screen or the slides or anything as I talk, you might want to exit the meeting and rejoin or reload the software, maybe try a different browser. But everything's operational as far as I can tell. Okay, sorry about that. All right, Internet Protocol, IPv4 and interfaces WAN. Obviously, if you have multiple WANs, you could just pick one WAN and use that. Remote gateways, far side. I just got a generic description in here. Tunnel to remote. Authentication method. Just for ease of what I'm doing here today, I'm going to use mutual pre-shared keys. Like I mentioned earlier, you could use RSA if you want to use certificates, but for pre-shared key, I just basically made up a long password for the tunnel. For the identifiers, this is just a simple case where I'm using the IP addresses on each side. There are times when you can use different formats of things like either like an email address style ID or a host name or something along those lines. Generally, you don't need to get into that. The vast majority of tunnels will build just fine using the IP addresses as your identifiers. You might need to adjust that if like one side is behind NAT or if one side has special requirements or a vendor wants you to use a different ID, that sort of thing. For the encryption algorithm, I've got AES 256 chosen here, which is a good choice. For phase one, hash algorithm, I've got SHA-256, and DH group is 15, and lifetime is 28,800 seconds. So these are all up to you and between you and the other side. As long as you both match, you're fine. You just need to make sure all these settings line up and that you both support the same set of options. The advanced options down here, most of the time you don't have to mess with these. The defaults are okay. Disable rekey. We've had some third-party equipment that we connect to not like the rekeying method that is used by our side. So if you check that, then it will be up to the far side, or it will maybe drop and renegotiate the whole thing. I can't remember the exact method of operation for that one. Similar with reauthentication, when it comes time to rekey, rather, in IKV2, you have an option whether or not you want to reauthenticate the peer. Responder only will stop your side from initiating the tunnel. Some vendors may have a requirement, make that a hard requirement for that. In other cases, you might find that, due to the way your networks are structured or the fact that one side is behind NAT, you can't initiate the other way. So you may want to set this on one side if you know the far side is going to be behind like a dynamic NAT of some sort. That last one, Mobike is an IKV2 specific option. That if you have that enabled, then it will be able to more easily accommodate a peer that changes IP addresses. So especially if you got something that's dynamic or might hop. Dead peer detection allows you to allows the IPsec daemon to send a little message, hello, are you there, to the other side, and if the other side doesn't respond, within the threshold defined by these settings, it will drop the tunnel and try to renegotiate it because to allow the connection to be rebuilt. If you're on IKV1, you'll also have a NAT traversal option down here that you can set. You generally don't want to have, you don't need to force that in most cases unless one side is behind NAT, or you might find in certain cases too where ISPs are interfering with your IPsec tunnel traffic, like the ESP traffic. We've seen cases where ISPs will interfere with that, and forcing NAT traversal can help work around that. All right, so that's it for phase one. Save all that and hop back over here. Click down here and you'll see the phase two definitions. Now, phase two definitions control which networks will be sent across the tunnel. Right here, I've got my local network, which is my LAN. You could, if you want to, choose LAN subnet here and it will automatically fill that in, but I wanted to kind of see the symmetry here between the two sides. So my local network on this side is 10.3.0.0. The remote network here is 10.4.0.0 because that's my other site. I don't need NAT in this case, but if you do need a NAT, you put your actual real local network up here in the top box, and then you pick like the same type down here, and you can NAT to a completely different network if you have to. Now, when it comes to encryption, again, you have to match what the far side wants on, or what you agree to. In this case, I'm using AES 256 GCM and no hash because the hashing is done by AES GCM. However, it's very common to see like sort of similar to your phase one where you've got AES 256 and SHA 256. You can do multiple. You can allow multiple selections here, and it will kind of dial in on something that it can use on both sides. But that can slow down negotiation. So if you know there's a good set that you want to use, it's best to only select that one set of options. Same with PFS key group, similar to the DH group on phase one. And lifetime is the how long it's going to take until this needs to be expired and rebuilt. Automatic ping host will let you define a host on the far side of the tunnel, and it will try to send some traffic to that host and to keep the tunnel up or bring it up. And that's it for phase two over here. And then we need to go over here on the other side and do the same thing. VPN IPsec. And we've got our phase one. It's pointed back to the other firewall. The exact same pre-shared key. And this is a random key that I generated using a password generator. So nice and random there. The longer the better, and the more special characters and other stuff you can put in there, the better. It all matches up to AES 256, SHA 256, 15, 28.8, and the exact same settings on both sides. And obviously IPv2 and everything is set identically. When it comes to phase two, the encryption, everything is identical, but you notice the networks are flipped because to this one, 4 is local and 3 is remote. And if you need to carry multiple networks across here, you just define additional phase twos. Like say this side over here had 10.5 as well. I would just define another phase two that had 10.5 to 10.3. And then over here on the first side, I'd have another one that had 10.3 to 10.5. So if you need more networks, you just add more phase twos. Now, once the tunnel is built, you do need to accommodate the traffic with the firewall rules. So you come over here under Firewall and Rules on your IPsec tab. I have a rule that allows for all. And when you make a rule like that, if I add a new rule here, you'll notice the protocol defaults to TCP, which will only allow TCP. That won't allow things like ping to pass. So if you're just going to allow anything, you want to make sure you set that protocol to any. And then when you save that, it's going to come back as allow any rule like this. You can be as strict as you want with that traffic, only passing certain things from certain sources to certain destinations. That's entirely up to you, whatever you want to allow. And in a case like this, where both sides need to reach, pretty much whatever they want to at either side, you do need to have rules on both sides. And these rules govern the traffic that is coming into this firewall from the far side. So in this case, right now I'm looking at the side that houses 10.4. So these rules here are going to match the traffic that's coming from 10.3 to 10.4. And that's coming in the IPsec interface. And since the firewall rules are governing traffic entering, they will match these rules. So if you only needed to go in one direction, you would only need rules on one side, whichever side is receiving. If you need to allow in both directions, you got to have rules on both sides. So you just have to make sure you pass everything you need to pass. And if your traffic isn't working and if the tunnel comes up and your traffic isn't working, you'll see that in the firewall log. Similarly, if the IPsec tunnel doesn't come up, you'll see that in the IPsec log. If we check the status here, status IPsec, you can see I've got this tunnel's up, and this under status IPsec, you'll see it shows the exact settings that it connected with and how much traffic is passed. And if I want to test this, see, I'm on the 10.3 side trying to go to 10.4. If I go to diagnostics and ping, I want to try to ping 10.4, 4.0.1, and I'm going to ping that from a source of my LAN, which is 10.3.01. Just make sure we can pass some traffic. And there we go. See, it sent a ping to 10.4 from 10.3 and it got a response. So we know the VPN is up and passing traffic. If I go back to status IPsec and look here, there's some traffic in and out. And you can disconnect and connect the tunnel here using the controls on the IPsec status as you need. And if for some reason it doesn't work, you can go into the IPsec log and you should get some clue as to why it's not connecting there. Or if you see nothing in the log on one side, when you try to initiate from the other, then something may be blocking your traffic in between, or it may be connected to the wrong peer address, things like that. We have a whole IPsec troubleshooting page on the wiki. It's pretty detailed. It goes over analyzing the logs and setting up your logs for good debugging and some things to check. So if you have trouble getting that tunnel up, visit the wiki and you should be able to get that going. Okay, that's it for IPsec. Because we got a tunnel going up between the two sites. Now we're going to do an OpenVPN site between, one of the VMs we were just on and a third VM that's using something different, just because remember they can't overlap. So when you go with OpenVPN, you have to pick one side to be the server, and generally you'd want that to be the side that has a static address, or it may have more bandwidth, or it may have a beefier bit of hardware. It's entirely up to you which one you want to use for that. And then obviously you have to pick that tunnel network that I mentioned before. So I picked this side over here to be my server. And I've got this all defined here. What you need to do is when you first create a server, you want to set it to peer-to-peer shared key. Leave it on UDP and TON. It's on my WAN. I've got this on port 1195 because I had a remote access server set up on 1194. I put in a description here. In shared key here, this isn't filled in by default, but there's a checkbox that will automatically generate that. The first time you save it, it generates that key, and then you'll have to copy and paste that key over to the secondary. So I'll come back to that in a moment. When you have encryption algorithm and auth digest, they're sort of like similar to the equivalent settings in IPsec. However, these, again, it's entirely up to you as long as they match. Here's where I filled in the tunnel network I chose earlier. I just used 10.3.100.0/30. This gets filled in on both sides. And now down here in the remote networks are where I list the network that is on the LAN at the far side. This is equivalent to like in the phase 2 remote in IPsec. Because in shared key, you can't use the local network boxes. You just have to fill in the remotes on both sides. So I just filled in 10.5.00/24 since that's the network that's at the far side here. And if you have multiple networks, you can put them in here comma separated. Like if I had another one, I could do 10.6.00 like that, if there was another one. Whatever you want to route across the tunnel, you need to fill it in the remotes. And the rest of the settings you can really leave at default. You can set up compression if you want. It's optional. If you're sending data that can be compressed, you might get a little bit more speed out of it at the cost of a little bit more CPU power. That's pretty much it. When you save, it's going to generate this key for you, and you'll come back here, select all and copy it out. And then when you go to the client, you'll want to paste that in. On the client, you go to OpenVPN, VPN OpenVPN, and you go to the client tab. And it's just about, and from here on, it's just about making it line up with the server. You got to set it to peer-to-peer shared key, UDP on my WAN. The server address is the host name of the server or the IP address of the server. Server port, it's the port we chose on that other screen. It's 1195. Description, I just put tunnel to HQ. You can do whatever you want there. Shared key, you do not want to generate a new shared key on the client. You'll want to uncheck the automatic box that comes up when you first start this. And then this box will be empty, so you just want to paste in that key that you copied from the other side. Then set your encryption and auth to match the other side. Fill in the exact same tunnel network on both. It'll figure out which one it needs from there. And then for remote networks, you put in, again, the network that is on the other side of the VPN, the far side. So the main site here is 10.3.0.0. So that's what I put in remote. And then compression you can set up if you want, whatever. Then save, and that's done. Now, one more step on the server. Just like with IPsec, you do need rules on the OpenVPN tab, identical to IPsec. If you want to add an allow all rule, you go ahead and add it. Just make sure you set the protocol to any or set up the specific rules. Let's see. On OpenVPN, though, you do need to add a rule on your WAN to allow the traffic to reach the OpenVPN port. So in this case, I knew the remote site has a static IP address, so I wanted to set this up to be strict. So I only allowed traffic from that source, but any source port, you need to leave that source port as any, because it's going to be a randomized source port in this case. You can lock that down if you want, but most people don't. And if you put that in the rule, it's just going to mess it up if you don't set it up properly. So most of the time, you're just going to leave that as any. Destination is my WAN address, port 1195. And that's just where it went. And then once that rule's in place, the far side can connect. And if we look at our OpenVPN status, tunnel shows up. And just show you, I do have OpenVPN rules set on both sides to pass the traffic back and forth. And you can do the same test with this that you did with the other. If I want to ping 10.301, the difference is with OpenVPN, you can do two different ping tests. If I leave the source address as default, it's going to send that ping from the VPN interface itself. And so it doesn't show you the source here, but it didn't actually send that from the LAN address, it sent it from the VPN tunnel network. So that, the 10.3.100 address that we had. But if I set this to LAN specifically, there, now we see it sent a ping from 10.3.01 to 10.5.01. And because I got a response back, I know my LAN to LAN routing is okay. An additional thing you can do to check, besides looking at status OpenVPN on here, say the VPN connects, but you're not passing traffic. First, obviously check the firewall rules, but you can also check the routing table. Now, the routing table on OpenVPN, because OpenVPN does cohabitate with the routing table very well, you'll see like an entry here. I'm on the remote site. It has a link or a route in the routing table pointing 10.3.0/24 back to the first site. So that's all happy up and working. Oh, I must have missed this. There was Matthew asked why no hash. Oh, that was with on IPsec. I didn't set a hash with AES GCM because that's what I was using for my encryption algorithm. AES GCM has hash built into it, so you don't need a hash with AES GCM. But if you use something like AES 256, you'd have to set a hash, like SHA-256 or whatever, or SHA-1 or whatever you want. Sorry, but a little backtracking there because I missed that. Okay. Now, I don't have a demo set up for this next part, but I figured I'd tell you a little bit about how to extrapolate from here and go to more sites if you need them. When you connect multiple sites like 3, 4, 5, 6, 10, 20, whatever, there's two main different philosophies you can go with, either a mesh or hub and spoke, which is also called star. With mesh, you have every site has a VPN to every other site. So like say you've got 5 locations, every location is going to have 4 tunnels, one to every other location. So n-1 tunnels on every firewall. And as you can probably tell by that, it scales very poorly. It's lots to administer. If you want to add an additional site, you have to add tunnels to everything. So you got to touch everything just to add another site. However, because even though it scales poorly, it's the most efficient use of bandwidth. If your remotes talk to each other, the traffic goes right there. It's more failure tolerant because if your hub goes down, you don't have to worry about anything remote to remote. The remote sites can go and operate independently if you want. Now, the other major one is hub and spoke or star. You have a central server, and then all remotes connect to the hub, so all traffic passes through the hub. So if your sites C and D want to talk to each other, that they talk through the hub. So because it does that, it uses a lot more bandwidth at the hub, but you also have a lot more control over what they can do because you're managing all that centrally. So it's a lot easier to configure because you just have to set up, um, you just have to set up either, like your routing or phase two entries, and you have your additional tunnel. Depending on your setup, you may still have to touch the remote sites to, let it either add another phase two or add another route or something. But if you're careful when you design your network, you can do away with a lot of that with CIDR summarization. Like if you have everything under 10, not something, you could have the VPN just route it or send all 10 traffic to the hub. Um, but the downside of that, even though because it's easy, if the hub is down, then the remotes are all down, they can't reach each other. In some situations that may be okay, like a retail chain type situation, your stores probably don't ever need to talk to each other. They probably only need to talk to the hub. So mesh would be overkill in a lot of situations. Uh, and so it's all a matter of preference and what you feel like administering. But you know, the for most people, hub and spoke is a lot easier to administer. But like I said, mesh is more efficient and fault tolerant. So all what you want to do. IPsec and OpenVPN can work either way. If you're using OpenVPN, mesh would be easier with shared keys in most cases, so you could use PKI. Hub and spoke is easier with PKI, sort of what I touched on a bit ago. Um, you will have to set up like the certificates and everything else, but you can do a lot more with OpenVPN and PKI to automate the clients to where the clients really only need to know that connect back to the server, and the server can push all their routes and everything out to the clients. It's a lot easier when you get to a lot when you get to I think all your administration is on the hub in that case. Very little on the clients. IPsec, if you want to do that, you're going to be in a similar boat either way. You're either going to have many phase one entries in a mesh setup, or you're going to have many phase two entries in a hub and spoke. But again, you can reduce that with good network design and summarization. Okay, a simple three-way hub and spoke IPsec example here. So your site A is your hub. You'd have a phase one that would go A to B, and it would have two phase two entries. The first one for all traffic from A to B, and the second one for C to B. So any possible traffic path has to be accommodated for here in these phase twos. Your second tunnel at the hub goes from A to C, and it has phase twos that carry A to C and B to C. And then at your site B, you have your tunnel back from B to A, and it has phase twos for B to A and B to C. And then at site C, your tunnel goes C to A with phase twos for C to A and C to B. So just like I said, any possible path of traffic has to be accommodated for in phase twos. So if you leave out that second phase two on one end or the other, it's not going to work. Because even though the hub connects both to B and C, there's nothing that would define that policy that would allow that traffic to go from C to B unless you accommodate for it in the phase twos with IPsec. A little bit different with shared key. Say you've got like at the side A, you've got a server for A to B, and in your remote networks you just say B because B is the only thing at the far side of the tunnel. And you've got your server AC, which has the far side network listed as the LAN at C because it's the only thing at the far side of that tunnel. Now on your clients, site B, in that client for site B, you define the remote networks as A and C because those are on the far side. And similar at site C on your client back to AC, you've got the remote networks of A and B LANs because they're the remotes to you. OpenVPN, because it's not policy-based and it's route-based, it has the routes already in the operating system that know if a packet comes in and tries to go to B, it's going to go down the VPN tunnel to B. It doesn't care so much about the source. You could still limit that with firewall rules if you want. And so, if you just keep adding networks in your remote networks at the remote sites, and they'll all route back to the hub, and the hub knows how to route between them just by having the routes in the routing table. So easier in some ways, a little bit more confusing in others because it's not clearly defined in the VPN that you can get from one to the other, but nevertheless it works. And so for a lot of people, it's easier to make it work with OpenVPN because they don't have to worry about adding all those additional phase twos. All right, well, that's really all I intended to cover today. So if anybody's got any questions or comments, whatever you want to drop in the chat, just let me know. All right, so if somebody's got a question, so go ahead and keep typing. See, IPsec, are your settings the best balance for security and performance? The settings that I showed you here are the best for both on hardware that has AES and I acceleration, like our SG series firewalls that we sell, or like the C2758 or XG units. The boxes we sell all have AES and I, and so the settings I showed you here are the best to use on those, just because it will be accelerated and you'll get on, at least on, I think pretty much any of them will do several hundred megabits of IPsec with those settings. OpenVPN Shared Key DNS can't seem to get it to pass, multi-site. With OpenVPN passing traffic, it's all down to your routes and rules. If something isn't responding, then you could be missing a route somewhere. The rules maybe not be allowing it, or with DNS, there could be a couple of other complications there, where if your DNS forwarder isn't listening to all the interfaces or it doesn't know to accept that traffic. If you're doing a selective binding or something in your DNS forwarder or resolver, it may not be accepting that traffic. If you're using the DNS resolver, you may have to add your far side networks like the access lists in Unbound so it knows to accept those queries. There's several things that could be going wrong there, probably more than I'd have time to get into today here. But if you need help with that, if you've got support, you can drop us a line or drop a note in the forum. It's probably just a simple one-liner missing somewhere. I'm betting if you're using the DNS resolver, it's probably just missing like an access list entry. See, OpenVPN, can the same server be used for site-to-site and individual users? If you're using an SSL TLS type setting, it is possible, but I would not recommend mixing them like that. There's really no reason to, and it can get confusing and ultimately end up reducing your security if you try to do that. I would steer clear of it. I've seen it work before, but I'd steer clear of it. Can you set up 2 OpenVPN servers on the same pfSense? Yeah, you can set up as many OpenVPN servers as you want, really. There's no limit we impose on that. They have to be on different ports, and they have to be using different tunnel networks. But other than that, you can set up dozens of them or hundreds. Let's see, does the keep alive ping tie into the pfSense notifications, like if a VPN link failure equals an email to the admin? Not with IPsec. And in OpenVPN, that would only come in if you have it assigned, because it would be generating a gateway. It would monitor that gateway by default, and the gateway monitoring would send you an email, but not generally something that would happen for all VPNs. That's something that you'd want a real network monitoring system on one lane or the other to monitor something on the other side of the VPN to do that. You wouldn't necessarily want to track that by having the firewall monitor the VPN status. Let's see. IPsec, in order to take advantage of AES-NI, all firewall need to support this, correct? It depends on the speed of your hardware. If you've got a gigantic beefy box on one side and a smaller box with AES-NI on the other side, AES-NI could help that smaller box keep up with the bigger box, but ideally you'd have it everywhere. There are so many different things that could be your bottleneck. It's hard to say, where it's going to help you the most, but modern hardware is going to have it, good hardware is going to have it, so you may as well enable it. We just need to make sure that all sides involved support not only AES-NI, but the AES GCM ciphers that it can be accelerated with. Anybody else? had the chat up on a different screen, but I'll put it up here. All right. Looks like we might have another question coming in here. Is there a doc for the best IPsec settings? We have the doc wiki. I don't think it's got updated to have these. However, I did very recently revise the IPsec chapter of the book to have these settings in them. So you can either refer back to the slides for this presentation, which will be up in the they'll be up in the portal later today or over the weekend, or you can look at the book, which should already have the most latest copy up there, at least the HTML version. All right, anybody else? Any more questions? Oh, you're welcome, Pat. Thank you. Thanks for attending. I think between this Hangout and the previous 2 months I did on remote access VPNs and the ones we've done before on IPsec and OpenVPN in other ways, I think we've covered just about everything. But it's good to have something periodically, because this one we already did one on IPsec over a year ago, probably a year and a half ago, I think. But things have changed over time, obviously with acceleration and the new ciphers and the new systems we've picked up. So it's good to have a refresh every once in a while. Some things rarely change over time, but this is something that we've had some significant changes, especially with 2.2 and the additional ciphers and things we've picked up. So really a good thing. So all right. So if there's nothing else, I guess we'll call that it for today. And so we'll see you all back here next month. Thank you very much. Have a good weekend. Have a good holiday. Oh, no, Simon, if you look back, we have the Hangout archive, all of the previous videos and slides and everything for every Hangout we've ever done. They're available in the portal. If you just look in the Hangout archive, when you log into the portal, you can get to all of that. So you can, any topic we've already covered, you can always go back and review it, and it's there for everybody. All right, see you later.